In cold environments, microorganisms are the kings. They form the basis of fragile ecosystems, which are menaced by global warming. These creatures possess astonishing equipment, which allows them to survive in these hostile environments. Their adaptations are of particular interest to scientists. We're going to follow their trail to the coldest places on Earth, to Spitzberg, Greenland, and Antarctica. Spitzberg is an island in the archipelago of Svalbard in the Arctic Circle. It's an extreme environment because of freezing temperatures that can drop as far as -30 degrees. There are but 2 seasons, 9 months of long, dark and glacial winter, followed by 3 months of short, sunny and cool summer. The Spitzberg scientific expedition has the mission of cataloguing the microfauna and flora during that short summer period. The expedition is made up of biology students, accompanied by their teacher, Jean-Michel Bichin, researcher at the Museum of Natural History in Paris.
According to him, that's the best place, and we can land easily with the Zodiac as well.
All the team will spend a month on the island, relying only on themselves.
We have to see if there's a stream, so that we can have water during our stay. If we can find a dry spot that's a little elevated, that'll give us an observation point. Beside the mountain wouldn't be bad to shelter us from the valley winds, as well as to see any visit from a bear.
Cataloguing the biodiversity of Spitzberg means confronting 3 extreme environments: glaciers, steep cliffs, and tundra. To this rather unwelcoming picture is added the presence of polar bears. These lords of the ice are often presented as the principal victims of global warming. But along with the polar bear, thousands of species are menaced with extinction, and some haven't even been catalogued yet.
We know that global warming is going so fast that the Arctic ecosystems are in immediate danger, which means we consider they will survive between 25 and 50 years. So that's the context we're in as an Arctic biodiversity expedition. We're responding to a really urgent need, that of knowing more about the endangered ecosystems.
During the brief summer season on Spitzberg, the sun never sets and shines all day. It's the ideal period to study the vegetation, which is in full growth. Come on, off we go. On its first day, the expedition will attack the great flat areas close to sea level where the tundra develops. This vegetation hugs the ground and is perfectly adapted to the Arctic environment. Even though the surface layer of soil melts during the summer, it is poor in mineral salts. This limits growth rates and density of the vegetation considerably.
As soon as there's a shelter where seeds can build up, where sediment grows, vegetation finds a place immediately. There you've typically got a pretty clump of dryas settling in. Once the plants have rooted down there, they'll try to colonize around them. You see it here, for example. So, roughly speaking, the aim is to hang on and then gain centimeters here and there.
So how did these plants manage to colonize cold and completely barren terrain? They take the form of a compact cushion which allows them to store heat. It's an efficient means of conquering terrain because certain plants can live for more than 100 years.
There are two explanations for that. It offers good wind resistance, but this compact form also protects from the cold, and beside that, the plants will die and thus create their own humus, their own organic matter for those plants that come after. So in fact, they create surface soil made up by the generations of plants which die in that place.
These cushions of vegetation thus serve as compost for other plants, such as Pedicularis hirsuta, the hairy lousewort. This plant, which is perfectly acclimatized, makes a sort of duvet to protect it from the cold. Its hairs are wrapped so tightly that they imprison air and act as thermal insulation. They also block harmful rays from the sun. What is more astonishing is that the densest and most developed vegetation is to be found in an even more extreme environment, on the sharp slopes of cliffs.
Hey, look there. You see, just there, you've got areas of rock slides, and between the rock slides, at the foot of the pillars there, you've really got an area with green platforms. I think we should take a look over there. We're going to climb it there on the flank. We don't really know what type of terrain we'll meet. It's probably unstable ground. There are really some highly eroded places. As in every biodiversity study, reaching the ecosystems isn't an easy task for some of them. That's also the reward, taking a certain number of risks to get to places that sometimes no one has ever observed. Such as this zone here, which is an extreme zone within an extreme place. Well, that's unexpected. Really unexpected. We've got plants with fruits and flowers.
But how do the plants find organic material in such an inhospitable environment?
The fact of finding plants at a more advanced stage in this environment, suspended from the cliff flank, 100 meters up, is really very surprising. At the same time, it's not really a mystery. We're just below a bird colony, so crudely put, here the food falls from the sky. Here there is guano, brought by the birds, which brings nitrogen, a nutritive material, which allows a whole lot of bacteria, mosses and lichens to colonize this site.
To completely catalogue the microfauna of Spitzberg, it will be necessary to approach these migratory birds who carry many parasites. Notably ticks, who travel well attached to the feathers of their hosts. They come from very far away, sometimes from hot countries, to conquer Spitzberg. A voyage sometimes made at the expense of the bird. As the ticks drink the bird's blood, they also give them Lyme's disease.
Ah, look, an Arctic seagull. This body isn't very old, and probably comes from the big colonies you can see at the top of the cliff. So there's no other way of observing them close up, except by the bodies which are found at the base of the cliff. On some of these birds, you can see, that's what I'm trying to do, whether there are parasites. Here in this is a real thermal blanket for acarians. Not only is there no chance of falling off, it's also very warm.
But the soft warmth of this blanket isn't enough to survive such a long voyage. Some ticks have developed exceptional resistance to variations in temperature. They can go from 40 to -30 degrees without any difficulty. How can the tick resist polar temperatures without its blood freezing? By producing an antifreeze, glycerol. Thanks to that, their cells only start to freeze beyond -20 degrees. So it's not surprising to find ticks in the most inhospitable places on the Earth.